Greetings, I'm Dr. Mark Williamson, a statistician for the Bird Corps. Today, I'm presenting my poster on recent brain cancer research that I collaborated with Dr. Maren Klug and Dr. Gary Schwartz on. We focus on brain cancer, in part because it's a very deadly form of cancer and it has a poorly understood etiology. The only really known risk factor is ionizing radiation. So there's been a lot of past studies on nuclear power reactors and brain cancer, mostly like cohort studies of nuclear reactor workers, but there's really been mixed results on risk of cancer, including brain cancer risk. So what we did was we took state level brain cancer incident rates and compared to the number of nuclear power reactors per state in sort of a hypothesis generating study in order to dig into more of maybe other possible etiologies. So we took state level rates of brain cancer, the latest 5-year incidence for whites, because whites have the highest rates of brain cancer, and we separated them out by age and also sex. And we included nuclear power reactors and then nuclear research reactors, two different kinds of reactors, and also controlled for income and education because higher socioeconomic status has been associated with higher incidence rates. And then we also included radon levels because that's another source of ionizing radiation, a potential confounder. So what we found was there was actually a significant relationship between brain cancer incidence and the number of nuclear reactors. We see these graphs here. As the number of research reactors per state went up, so did incidence. This was found in males and females for all ages, males only, all ages, and then males for 50 and older. And so this was pretty surprising because it turns out it was research reactors rather than power reactors that were significant. And then we actually followed up with a county level analysis and then found that counties with a research reactor on average had higher rates of brain cancer than the state average they were in. Now these results are really interesting because research reactors are actually much smaller, usually found on a university campus, and seem to be much less likely to have sort of a oncogenic effect. They're not going to be as likely to have like some sort of environmental contamination, such as like treated water, etc. But maybe what's going on here, we try to control for all confounding factors. There's an unknown third factor, or it really might be a cause here. A great future test would be to examine radionuclide load in the brains of those who died from brain cancer compared to a control source to see if there's any merit to this. Anyways, thank you for your time.